Now we have seen that how to find out the maximum and minimum value in both the cases, if it is a modulus function or if it is a whole square polynomial of 2 second order. Now if I am asking you, if it is a trigonometric function or polynomial of degree 3, 4, 5 like that, how to find it out? To understand that maximum and minimum value, we have to learn one theorem. Just I will tell you that theorem, just remember as a formula. There are some steps are there. What is the step? Step 1. Step 1. Y equal to fx is a function. It will be given y equal to fx is a function, and you have to find out step 2. Step 1 dy by dx, you find it out. F dash x and d square y by dx square double derivative equal to f double dash x. Do you understand what I am telling? This will be given to you, and you find out the first and second order derivative, and you write step 2 for the optimum value f dash x equal to 0. For the optimum means it may be maximum, it may be minimum. We don't know whether the given function has maximum value or minimum value or having both. We don't know. So that's why we are writing for the optimum value that f dash x is equal to 0. Then if you put f dash x is equal to 0, then you will get, suppose then if you write it in the factorized form, x minus a, x minus b, x minus c, and so many may be there. Now, so f dash x equal to 0 means x minus a into x minus b into x minus c equal to 0. Whatever function you will get, you make it factorize, bring it into the factorized form, it will be easy to find it out. So x minus a equal to 0 implies x equal to a, and x minus b equal to 0 implies x equal to b, and x minus c equal to 0 implies x equal to c. Now 3 values of x you got it here. How many values of x? 1, 2, 3. What are they? A, B, C. These values of x, step 3 put this value of x in f double dash x, f double dash a, f double dash b, f double dash c. Put the value of x which you have got from f dash x equal to 0, you put the value here. Then what will happen? Then you check. If it is less than 0, it may be equal to 0, it may be greater than 0. If it is less than 0, equal to 0, greater than 0, here you can say if it is less than 0, remember it will be maximum. Neither maximum nor minimum. It is minimum. So remember, if you put the value of x in the double derivative, it is called double derivative test, then what we will get? This you can see the value of f double dash a, f double dash b, f double dash c. If you are getting it is less than 0, then what you can say? The given function has local maximum value at x is equal to a. If you see that double dash c is greater than 0, then you will say the given function has local minima at x is equal to c. And if you see that it is equal to 0, then you will say the given function has neither maxima nor minima. Has neither maxima nor minima value. So then this is the test. This is not your exact value. We are going to find out the maximum value and maximum minimum value. After putting that second order derivative, the values of x, you will get where it is maxima, where it is minima, whether it is not maxima, not minima. So this is the testing. This is not the exact value of the function, minimum value or maximum value of the function. So what will you do for that? The value of that, if you have to put the value of in the given function, you have to put the value of x in the given function. There, from here, which one is maximum, which one is minimum, you can find it out. You can find it out. So, in that cases, what will happen? Then, and here, if it is given x belongs to p comma q. So here also you have to find out if p, f, q. This also you have to find out. So out of these 5 values, which one is the greatest value, that will be maximum, and which is the smallest value, least value, this will be the minimum. Now if we find from here, this is that what we have is local maxima, local minima. The value which you have got from f dash x equal to 0, that value will say that the function has local maxima or local minima. Within that, within ABC, we have to say the function has local maxima and local minima, and that value will be given by this way. But after considering the boundary point also, after considering the boundary point, it is not boundary point when we consider. After considering the boundary point also, what we can say, if it is fine, if we find that here PQ, FP is the greatest one. So FP is the global maxima. Global maxima. And FQ is the least one. FQ, that is the least global minimum. Global minimum. So, but it is not necessary there will be, it will be the greatest one, it will be the smallest one. Not necessary. Out of that, if you see that FA is the local maximum to high, after putting this all this, getting all these values, if you see, still it is greatest value. So what will you say? That the given function has local as well as global maxima at x is equal to a. It is local to high. After getting all these values, boundary points, if you see that this is still greatest value, then what will you say? It is local maxima as well as global maxima. Alright, but if you see that FC is local minima, but FQ is the global, it is the smallest one. After getting the value, functional value, you see that FQ is the smallest one. So Fc is the local minima, but Fq is the global minima. Fc is the local minima and Fq is the global minima. Global will be considering when you will find out the functional value, of what these values A, B, C and the boundary points, including all these boundary points. If you find out the values of the function at those points, you can say which is the greatest one. If local maxima become global maxima may happen, or local minima is also global minima, that also may happen or may not happen. Look at my point. Now third question you see, third question, that is number 3, sin x plus cos x. This is your hx equal to this, and it is given x is greater than 0 but less than pi by 2. That means the angle is in the first quadrant angle. Now h dash x equal to cos x minus sin x. H double dash x is minus sin x minus cos x. For the optimum value, h dash x equal to 0 implies tan x equal to 1. Tan x equal to 1 implies x equal to pi by 4. Why? Now x is in the first quadrant angle, so x equal to pi by 4. Now h double dash pi by 4. So what should be that? Cos sin pi by 4 1 by root 2 minus cos pi by 4 1 by root 2. So minus 2 by root 2 equal to minus root 2, which is less than 0. So the function has maximum value at x is equal to pi by 4. So the function has maximum value at x equal to pi by 4. And what is that value? Now h pi by 4 equal to sin pi by 4 plus cos pi by 4. So it will be 1 by root 2 plus 1 by root 2, 2 by root 2, root 2. So this is the value, maximum value of the given function. At which point? At x is equal to pi by 4. Now, next you see fx equal to sin x minus cos x, where x is greater than 0 but less than 2 pi. So what will be f dash x? Minus cos x minus plus cos x minus plus sin x. Now f double dash x minus sin x plus cos x. So for the optimum value, tan x is equal to minus 1. Tan x equal to minus 1. Now tan theta is negative. Tan theta is negative either in the second quadrant or in the fourth quadrant. So what can I say about this one? X is equal to pi minus pi by 4 or x equal to 2 pi minus pi by 4. So it will be 7 pi by 4 and x is equal to 3 pi by 4. There are two possibilities of x. If tan x is equal to minus 1, tan theta is negative in the second quadrant and fourth quadrant. So second quadrant means pi minus pi by 4 and fourth quadrant means 2 pi minus pi by 4. So it will be 7 pi by 4 and 3 pi by 4. So you have got the two values of x where f dash x equal to 0. Now what are now if x is equal to 3 pi by 4, so what will be that? F double dash 3 pi by 4, f double dash 3 pi by 4 equal to minus sin 3 pi by 4 plus cos 3 pi by 4 minus sin pi minus pi by 4 plus cos pi minus pi by 4. So it will be 180 minus theta. Sin 180 minus theta. Sin is a positive sin theta. So sin pi by 4 pi minus pi by 4 cos. It will be negative. So cos pi by 4. So it will be minus 2 by root 2 equal to minus root 2, which is less than 0. Which is less than 0. So what we can say? The given function has maximum value at x equal to 3 pi by 4. So you will write the function has maximum value at x is equal to 3 pi by 4, and what will be its value? Now f(x), f 3 pi by 4 equal to sin 3 pi by 4 minus cos 3 pi by 4. So what should be that? It is 180 minus theta. It is also cos 180 minus theta. So it will be sin pi by 4 plus sin pi by 4, sin pi by 4 1 by root 2, and cos it will be minus cos pi by 4 minus plus cos pi by 4 means 1 by root 2 equal to root 2. Equal to root 2. So this is the maximum value. What is the maximum value of the given function? Maximum value is root 2, and at which point? At x is equal to 3 pi by 4, where x belongs to 0 to 2 pi. Similarly, you will find out here the same way 7 pi by 4. 7 pi by 4, x equal to 7 pi by 4, then what will happen? X is equal to 7 pi by 4, so f double dash 7 pi by 4 equal to minus 7 pi by 4 means 2 pi minus pi by 4 plus cos 2 pi minus pi by 4. So 180 minus 360 minus the fourth quadrant, so minus plus 2 pi, so sin pi by 4, 2 pi minus pi by 4, that is also the fourth quadrant cos is positive, so cos pi by 4. So 1 by root 2 plus 2 by root 2 equal to root 2, which is greater than 0. So the given function has minimum value at x is equal to 7 pi by 4. At x is equal to 7 pi by 4. Now what will be the minimum values? The minimum value is f 7 pi by 4 equal to sin 7 pi by 4 plus minus cos 7 pi by 4. So it will be what? Sin 2 pi minus theta, 2 pi minus pi by 4, 2 pi minus pi by 4. The sign will be remain sin, but with negative sign, sin pi by 4, and cos 2 pi, cos is positive, sin pi by, cos pi by 4. So it will be minus 2 by root 2, which is, this is the minimum value. This is the minimum value. So the given function has minimum value at x is equal to 7 pi by 4, and what is the minimum value? Minus root 2. In this way you have to answer, and you remember this problem will be little bit lengthier but easy, very mechanical, very much mechanical. First you find out f dash x, then f double dash x, then f dash x is equal to 0, find the values of x, put the values of x whatever you have got in the double dash x, then you will see that less than greater than equal to 0. If it is less than 0, it has minimum value, less than 0 then it has maximum value. If it is greater than 0, it has minimum value, and equal to 0 has neither maxima nor minimum. And put those values of x in the given function, you will get the minimum and maximum value. Now question number 3. Question number 3. Find also the local maxima and the local minimum values at each cases may be. Fx equal to x square. By using the formula, it is 2x, and f double dash x is 2. So what did I tell you? For the optimum value, optimum value f dash x equal to 0. This implies 2x equal to 0, therefore x equal to 0. So f double dash 0, if you put f double dash 0, it will be 2, which is greater than 0. So the function has local minimum, it is greater than 0. So local minimum at x is equal to 0. So you will write it this way: the function has local minimum value at x is equal to 0. And what is the minimum value? Put that value at x is equal to 0. So f 0 equal to how much? 0. So minimum value is, and minimum value is 0. This is not the minimum value. It is a testing point. Double derivative test. Don't consider this as a minimum value. This as a minimum. It is just for checking whether maxima or minima. What you did it in this way, putting the value of x in the double derivative, and you will see that value of the f double dash x means f double dash 0, and if it is greater than 0, so we can consider, we will say that it is minimum at x is equal to 0. But this is not the minimum value. This is not the minimum value. Which is the minimum value? After putting x is equal to 0 in the given function, you will get the minimum value. Now, second one, you see, gx equal to x cube minus 3x. So g dash x equal to what? 3x square minus 3. So 3 common, x square minus 1. So g double dash x equal to 6x. Now for optimum value, once again for optimum value, g dash x equal to 0 implies x square minus 1 equal to 0 implies x is equal to plus 1 or x equal to minus 1. X equal to plus 1 or x equal to minus 1. Now you see that this value, when x equal to plus 1, then g double dash 1 equal to what? 6, which is greater than 0. And when x is equal to minus 1, g double dash minus 1 equal to minus 6, less than 0. So here you will write the given function has minimum value at x equal to 1, and the given function has maximum value at x is equal to minus 1. Now, what will be the minimum value? So, it is local minimum. So, if g minimum value we are going to find out at x g1 equal to 1 cube minus 3 into 1 equal to minus 2, and g minus 1 equal to minus 1 minus plus 3 equal to plus 3. So what is the minimum value? It is the minimum value and it is the maximum value. What is the minimum value of the given function? Minus 2. And what is the maximum value of the given function? Plus 2. Why? Minimum value is minus 2, maximum value is plus 2. This, it is local minimum and local maximum value. Fifth question you see, hx equal to x plus 1, and where x belongs to minus 1 to plus 1. Open it. That means x is greater than minus 1 but less than 1. So x plus 1 is greater than minus 1 plus 1 but less than 1 plus 1. So x plus 1 is less than 2 but greater than 0. So it is greater than, so hx is less than 2 but greater than 0. Hx is greater than 0 but less than 2. Now, if I ask you greater than 0 any number, what are you going to say? Nothing. So many numbers are there. Infinite number of numbers are there. So, what is the minimum value? We cannot estimate. Neither we can say about the maximum value. We cannot say about this maximum value. Why? The maximum value, it is less than 2. But what is the number exactly? The maximum value, if there is an equality sign would be there, then we can say. If it is hx is less than equals to 2 but greater than equal to 0, the minimum value is 0, maximum value is 2. But if I say there is no equality sign, so we cannot say at that time the minimum value and maximum value. Then I can say that minimum will be greater than 0 and maximum will be less than 2. This much, but the exact number, the exact value, minimum value, maximum value, we cannot say. So, the function does not have any minimum or any maximum values. Now, question number 4, third one. Question 4, third part. What is that? hx equal to x cube plus x square plus x plus 1. Now h dash x is equal to 3x square plus 2x plus 1. H double dash x equal to 6x plus 2. For optimum solution, h dash x equal to 0. This implies 3x square plus 2x plus 1 equal to 0. So x is equal to minus b plus minus root over b square minus 4ac by 2a, 2 into a. So minus 2 plus minus root over 12 minus 4, 8, 2 root 2 minus 4, 2 root 2I by 6. That is minus 1 plus minus root 2I by 3. Which shows that the value of x is imaginary, does not belong to R. So we cannot find any number for which the given function has maximum or minimum values. Now it is that